Okay, so the objective of this assignment was to create some sort of application that could search a text document and provide accurate results based off of the user query. Um, so my original intent was to actually answer the user's query. However, given the time, I didn't think there was really enough time to be able to do that. So instead, this application here finds the most relevant article related to the user's query. So now we're going to run the application, and to do that we first have to cd into the location of the file. This is running a Flask API. Okay, so now that we're in the directory, we have to execute a command that will then run the Flask app, which is flask_app, the name of the Python file that is to be run, and then followed by Flask run. So when we execute that command, it will come up and say it's running. We copy this link into our browser. And this is the basic design. It's very minimalistic. I didn't go for anything too complicated. So essentially, you enter in the query, press search, and it should come up with the most relevant article to the search query. So for instance, if we query, when did the Chinese Ming Dynasty exist, and we press search, it comes up with the most relevant article. Obviously, in the first sentence, the exact nature of relations between Tibet and Ming Dynasty of China is unclear, which means that this found the actual article that was most recent. So now what we're going to do is we'll go into the code. So for this, obviously the imports, we have to import Flask, the render templates, and the request in order to get the information from the HTML file into the Python file. So the render template is just essentially the HTML on the front, which is just, again, that minimalist approach that I took, so not very much. Obviously, it will find the result of the top article. So in order to proceed with this, I use something called a cosine similarity measure, which can tell the likeness of two documents based off of something used in search engines called term frequency inverse document frequency, or TF-IDF. That's a little complicated to do for this assignment, and I didn't think it was necessary. So instead, I actually used a built-in function of scikit-learn called count vectorizer. And this essentially counts all of the words inside of an article and projects it as a vector. So in order to do that, there was a lot of string cleaning that needed to be done in order to create a vocabulary. So this definition of word list vocab essentially cleans the articles and puts them in a list. Word list string cleans the articles and puts them as the first item in a list. So this is a bunch of words in a list, and this is just one article as in string in the list. The combine combines the words from the lists to make a vocab. This combines the articles from the data accessed that we were given. The definition of count counts the amount of words. This will be useful later when I fill in a matrix that I can then refer to later based off of word count. And then we have the cosine similarity measure right here, which performs the actual calculation of similarity. So when we have the definition top article, this is essentially where everything happens. We get the query from the user. We combine all the words in the articles into one list. We make a list from the query. We make the vocabulary a set, make that a list just to make sure that there's no duplicates, because you cannot have duplicates in a cosine similarity measure. You take the lengths of the files, so how many files are inside that text document that we got, and the length of the vocabulary. And then right here we fill a matrix with zeros. So this matrix is essentially empty from the beginning until we fill it later. So the next thing we do is we fill the matrix with the counts of the words. See, so here we are referencing the count method from above, or the count function from above. In here, this gets the keywords from the user's query. Nothing really special about that. It just takes out the stop words, so that way we're not looking up every single word that the user inputs. In here, what we're essentially doing is we're creating a dictionary based off of the word in the vocabulary and the index of the article in which it's stored. This can be repeated, so one word can be used in multiple articles. So for instance, this will actually provide a list output. So if there's a word in article 1, 7, and 35, it will show up as in articles 1, 7, and 35. So right here, we're indexing the array, or excuse me, we're indexing the matrix in order to find it, find the value that we're looking for. And then from there, what we're doing is we're finding the position, we're updating it if we have to in a dictionary. And this is essentially creating, this is locating the index of the array, that, or the index of the matrix that we have to look at later. And again, it's just a lot more referencing where the matrix are, or where the value is in the matrix. And then right here is where the actual cosine similarity measure takes place. So if all the words are contained in the exact same document, it will just jump right down to the cosine similarity measure, pull that, and essentially vectorize that article in the user query and send it to the cosine similarity measure. If there is more than one article, then all this is run. So for every article is pulled, vectorized, and then as well as the user query. And each one of those is sent to the cosine similarity measure. That's the results are stored in the list. The list is then translated into a dictionary that associates the index of the article with the cosine similarity measure, and then it finds the highest value within there and displays it. And that's about it.